Hi everyone. In this question we're going to be working on 2014 AP Calculus AB free response question. This was actually on the BC portion as well. The first thing that we're going to do is we're going to kind of understand what's being given to us. Typically whenever you see a chart like this, they're going to ask us to find the derivative between two coordinates, but also they're going to put us in scenarios which will require a final destination or a final position. So going ahead and reading this question, it says train A runs back and forth on the east and west section of the railroad track. Train's A velocity measured in meters per minute is given by a differentiable function v of a t, where time t is measured in minutes. Selected values of v of a t are given in the table above. Find the average acceleration of train A over the interval. Well, the first thing that's going to happen is we have to figure out what average acceleration is. That's our key word. So because of that, I'm going to highlight it. Your goal when you're studying for this is to always look for keywords. In this case, it happens to be average acceleration. Now, when you hear the word average, you think of your antiderivative 1 over b minus a, which is not bad. It's what you're taught to think. But the problem is, they're asking you for average acceleration when you're given velocity. Well, to go from velocity to acceleration, you have to apply a derivative, which is another word for saying slope, from 2 to 8. Now, the reason why this is the method to choose because average is another way of saying mean, and the mean value theorem is used to find a derivative or a slope between two coordinates, in this case 2 to 8. So because they're asking us for average acceleration for part A, we're going to have to find VA of 8 minus VA of 2 all over your endpoints 8 minus 2, which VA of 8 is negative 120 minus V of 2, which is 100 all over 6, and that's equal to negative 110 all over 3. And you have to be able to say what this is. Don't just leave it as negative 110 over 3. Make sure you're discussing what's happening. In this case, it's meter per minute squared. Okay? Now, knowing that, your next step is to go, alright, let's go to part B. Well, part B is saying, do the data in the table support the conclusion that train's A velocity is negative 100 meters per minute at some time t with 5 to 8? Okay, so between the time 5 to 8, is our velocity ever going to get to negative 100? So you're going to come to your solution or your coordinates and go, okay, from 5 to 8, is it ever going to get to negative 110? Or sorry, negative 100. Well, then you're going to think about the theorems that you learned in calculus, and the first thing that should come to your mind when it comes to this, you're looking to see if it's ever going to cross the coordinate. Well, you learned a rule which was called intermediate value theorem that told you if there's ever a location on an actual coordinate, meaning if I ever gave you a point that was down here, then I also gave you a point that was up here, and I told you that this function was continuous and differentiable, that means if I were to connect a line, it's going to have to pass through this coordinate, or this point that I'm looking for. Well, they're asking us to compare from 5 to 8 if it ever is going to pass through negative 100. So what you could say is this. Well, at V of 5, it's 40. And then V of 8, it's negative 120, so it's somewhere down here. Well, if this is continuous and differentiable, and I were to connect these lines, it would have to pass a negative 100 at some point. Because you're starting off at 40 and instantly going to negative 120 in 3 minutes. So because of that, I know it has to pass negative 100 at some point between that and that. And that's called your intermediate value theorem. So then what you could say, your definition is, well, because V of 8 is equal to negative 120, and V of 5 is equal to 40, negative 100 is between negative 120 as well as 40. Therefore, by the intermediate value theorem, and you do have to spell all these out, you can't use IVT in the shortcuts, there is a time from 5 to that V of A of t is equal to negative 100. Now they're not going to ask us to find this value. All they wanted to know, is there a time? And it is, because since it's continuous, you'll notice it jumps negative 100 at some point between 5 to 8. And that theorem is called the intermediate value theorem. Okay? So moving on to part C. Part C says, at time t equals 2, train's A position is 300 meters east of the origin state, and the train is moving to the east. Write an expression involving an integral that gives a position of train A. Key word, they're asking you for a position, and it's one of those formulas you just have to know. In meters with the origin state at time t equals 12. Use a trapezoidal sum with 3 subintervals indicating by the table to approximate the position at the train at time t equals 12. Trapezoidal sum. You have to know that formula as well. So then we're going to go, okay, well, to figure this out, we know that if I'm trying to find my actual position, that's pretty much going to be S of A of 12, which equals to my initial that they gave me, which was S of 2, plus the integral from 2 to 12 of V of A of t in respect to dt, which S of 2, we already know that's 300, plus the integral from 2 to 12 of V of t dt. Now the thing is, they asked you the specific way to find this area. They said trapezoidal sum. So you have to remember trapezoidal sum, and they told you that it was between 3 subintervals from 2 to 12 would be here to here, here to here, as well as here to here. Trapezoidal sum is the formula where I'm going to just take this 300 and I'm going to take it to the side, and you're going to multiply, well, what is the width of from 2 to 5? What is the width of that rectangle? 3 times, you're going to add up the two different heights, 100 plus 40, and then divide it by 2, plus 3, because 5 to 8, times 40 plus negative 120 divided by 2, plus the last one, 4, because the width of it is 8 to 12, 4 times negative 120 plus negative 150, all divided by 2. And you're going to work this out. And this is going to give you 300 plus negative 450. After you simplify this, remember, you don't have a calculator, so you have to do all this in your head. And then when you combine that, that gives you negative 150. That means the position of train A at time equals 12 is approximately approximately 150 meters west of origin station. Okay? So because they were asking you final position, you have to always include your initial plus whatever they're asking you to find. In this case, it was 2 to 12. They told you that S of 2 was 300. They told you to find this integral by using trapezoidal sum, which is the width times both heights divided by 2. Width times both heights divided by 2. Then you added all these up, combined them, you got negative 450. Added to 300, it was negative 150. Meaning that at time t equals 12, it was west of origin station. And then that's going to lead us to part D. And part D is one of the more confusing problems in this AP free response section. Well, part D tells you this. It says, a second train B travels north. Now we have to remember this. We had one train was traveling east, which we could say that we'll have it going this way. And then we have another train going west. Sorry, we have one train going east at, what was it? We have one train going east at 300 meters, so we know this is 300 meters. That's what they said in part C. And now we have a train station going, a train B traveling north. So this was A, this was B at 400. So a second train B travels north to Morgan Station at time t. The velocity of train B is given by this equation. And at time t equals 2, the train is 400 meters from north. So that's what we have so far. It says find the rate in meters per minute at which the distance between train A and train B is changing. So what that means is we're trying to find this distance right here as it's changing, either going this way or going this way. How far are they either getting away from each other or are they coming close to each other? So then we have to go, okay, it's asking us for a specific time. It's saying at which the distance between train A. So it wants us to find the rate. So because of that, because it's the rate, we have to figure out, well, what equation is this? How can we find that? And if you notice, this is a right triangle, meaning that this is going to be x squared, which I'm going to say this is x, I'm going to say this is y, and I'm going to give this the variable c. X squared plus y squared is equal to z squared. Now when you apply a derivative to this, because remember, derivative tells you rate, and I have to find the derivative at which this is changing, find the derivative of this is going to give me 2x dx dt, because it's an implicit differentiation, plus 2y dy dt is equal to 2z dz over dt. And then I'm going to go, okay, well, I already know that x is 300 because they told me in the beginning at t equals 2, position A is 300, so I know that I can say that this is going to be 2 times x, which is 300, and then my next step is, okay, well, I got to keep going with this. I have to figure this out. And once I have that, I'm going to go, well, 2 times 300 dx over dt. What was your velocity, because that's the first derivative, at 2 of train A? Well, remember, this is train A. Our velocity was 100. Plus 2 times y, which is train B, which we know this is 400. But then the problem becomes, well, what is my rate of that dy? What is that rate? Well, they told me that this is my rate right here, so then I have to take this aside and I have to actually plug this in. I have to plug in VB of 2 is equal to negative 5, 2 squared plus 60 times 2 plus 25, and you have to work all that out. And when you work all that out, that's going to give you a total of 125, meaning that the rate, the velocity of this train at time t equals 2 is 125. And I'm going to add that here because that's what dy over dt is. That's the rate at which this train is traveling. So I'm going to add 125 right here. Then I'm going to equal this to 2 times z, but the problem is I don't have z. But since it's a right triangle, I can also say that this is going to be found by 300 squared plus 400 squared equals to z squared, because of Pythagorean theorem. And then this is going to give you z is equal to 500. And then I can plug that in. 2 times 500, and then what I'm looking for, how the rate this is changing, dz over dt. And then you go ahead and simplify all of this and work it out. Remember, you're solving for this, and you're going to get that dz over dt is equal to 80,000 over 500, which is equal to 160 meters per minute. And that's your answer. Now, is this a hard one? Yeah, it is. But you have to think about what's happening. They told you one train was heading east, another train was heading north. They told you the velocity of this train at 2 minutes was 100, and it was 300 the position was 300 away. And they told you train B was this position was 400, but the velocity of this train was given by this equation. So we plugged in 2 into here to find the velocity of this, and then what they were asking us for is how far are the trains, either the distance on the train changing. Well, if you have 2 trains leaving or coming, this distance is going to change every single minute or every single second. So because of that, I had to figure out what shape was I dealing with, and that was a triangle. X squared plus y squared equals z squared. Then because of that, because we're asking for the rate, I have to apply the derivative. I applied the derivative, I worked it out. Every single one got dx over dt, dy over dt, dz over dt, and I plugged in the rates for every single one of these. Now because I was looking for the rate of the hypotenuse changing, I left it as it was, and then I simplified it, and I got 160 meters per minute. Alright guys, thanks for watching, hope to help.